Hello everyone, today we're going to look at usaco-training American heritage. Right, so in this problem, Farmer John has some cows, which each of them are labeled by some letter from A to Z, or in uppercase. So then obviously, Farmer John would have at most 26 cows. So then basically, there's a heritage, which means that so then all those cows would form a tree, or actually a binary tree in this example. Okay, so our job is to create the post order of the tree given the in order and the pre-order notations. Right, so for example, over here you can see that C is the root, and for C, its left child is going to be B, and its right child is going to be G. For B, its left child is going to be A, and its right child is going to be D. For G, its left child is going to be H, and it does not have any right child. For D, it has two children, E and F. All right, so we're given the in order and pre-order traversals. So the in order traversal prints out the left one, then the root, and then the right subtree. And the pre-order traversal prints out the root, then it prints out the left subtree, then it prints out the right subtree. And the post-order traversal prints out the left, the right subtree, and then the root. Okay, so over here, the first line is going to be the in order representation. So for example, over here it says that it would be left, root, and right. So then, from C, you would go left to B. From B, you would go left to A. And then since you have nothing to your left, you would print out yourself, which is the root. And then you would print out the right, which has nothing. So then you would have an A. And then you would move back up, and then you would print the root B. So you have B over here. And then you would move down to your right subtree. And then from your right, you would repeat this again. So you would print out left E. You would print out yourself D, and then you would print out your right F. And then after this, you're going to go back to the root and you're going to print out C. And then you're going to traverse to the right subtree to G. So, and then from G, you have to first print out your left subtree. So you're going to go to H. You would print out H. You would go back and you would print out the root, which is yourself. So for the in order traversal, you would have A, B, E, D, F, C, H, G. All right, so for the pre-order representation, you would first print out the root, then your left, then the right. So since your root is C, you would print out C first, or you're given C first, and then you're going to go to your left. Over here, for our left subtree, our current root is B, so we're going to print out B, and then you would go to your left subtree, and then you would print out the root, which is A, go back up, you would print out the right subtree. So to print this out, you would first print out the root, which is D, then you would print out the left E and F, and after this, you're going to visit C's right subtree. So then you're going to go to G and H. So you would first print out G because it's the subroot, and then you would print out H since it's at the left subtree. And then we're just going to print out the post-order representation. All right, so let's actually first write these strings down. So what we have here is in order. It's going to be A, B, E, D, F, C, H, G. And here is our pre-order, which is going to be C, B, A, D, E, F, G, H. All right, so the first thing that we're going to do is that we're going to determine the root, all right, or the root of the entire tree. So what we're going to do is that we're actually first going to draw the tree out over here. So we have, because we're not actually given, but we're going to try to construct this. So we have C, B, A, D, E, F, and G, H. All right, so we're going to try to find this C over here. Okay, so then notice that the pre-ordered traversal starts off with the with the root. So the first character over here is going to be our root. So then now we identified our the root of our entire tree because it's going to be the first character of our pre-order traversal. And now, knowing this, we're going to take a look back in our in-order traversal. Since what we have here for our in-order traversal, we have left, we have root, let's call this, yeah sure, root, and then we have our right. So then if we locate C over here, which is going to be at this position, we know that over here, this part is going to be the left subtree, and over here, this part is going to be the right subtree. So then knowing this, we can basically locate the size of our left and right subtree. So then what we're going to do here is that we know the size of our left subtree is going to be A, B, E, D, F. So it's going to be 1, 2, 3, 4, 5. And then our right subtree is going to be this. And then what we're going to do is that we're just going to keep on recursively finding this value. So right now we have located C. So now let's go to our left children. So then in this range, again, you know that your root is going to be the first character. So now we found this. And then over here, we're going to try to determine the position, which is going to be over here. So now we know that the left subtree is going to be here, and the right subtree is going to be here. Right, so after this, you're going to have this, and then our left subtree, and then our right subtree. So again, after this, we're going to go to A. We see that over here it has nothing since it's just a single character, so you're just going to escape that. So now we're going to look at the subtree, or actually we already found this, so we're going to look at the subtree D, E, F. So again, we know that the first character is going to be our root, so we found that. Now over here, we're going to be locating D, which is over here. And then we know that E is going to be our left, and F is going to be our right. So now, since that's only a single character, so then we found it. Alright, so again, similarly, for the right subtree of C, the first character over here is going to be the root, so this is going to be the root. And then over here for our H, basically, again, you would locate your G over here, so you have this character, and you know that your H would be the left subtree. So then we found it. Now we just locate these, and now we have our entire tree. So then after this, we just need to print out the post-order traversal. But since we already know the order of the tree, we can basically just implement that and print out the left subtree, right subtree, and then finally the root. Alright, so let's get coding. Whoops, alright. So over here we have two strings. Whoops. Alright, so let's just do that. Alright. So let's insert a snippet. Okay, so we have our in order. Let's just give this 30, and we also have our pre-order. Alright, so let's read these strings. And we're going to have n, which is going to be the basically the size of our whole thing. So we can have n equals to string length in. All right, so now we're going to create a search, basically from our in our pre. Okay, so what you're going to have here is that we're going to have the endpoints of our in our pre. So for our in, our start is going to be 0 and n minus 1. And for our pre, the same thing goes. So it's going to be from 0 to n minus 1. Okay, so now we're in our DFS. So let's call this I, J, and X, and Y. So over here, remember that we know that the first character of our pre-order traversal is going to be our root. So then let's just call this our root would be equal to pre-order of X. All right. So now that we got that, we're going to try to search this root character in our in-order traversal. So we have our K. Let's just give this to 0 by default. And then for each element from let's call this from I to J. So basically, if in of I is equal to K, if this is so, then we're just going to set K to I. Alright, so for example, over here you have your C, right? So you're going to locate it. This is going to be 0, 1, 2, 3, 4, 5. So now your K is going to be equal to 5. So now after this, we're going to DFS on our left children and on our right children. So then we're going to DFS. So this is for our left. All right, so you know that for your in order, your left start is going to stay the same, while your right endpoint is going to be K minus 1. And for your pre-order thing, you would start off at the x plus 1, since the first one is going to be your root, and then you're going to be basically adding the size. So this is going to be x plus K minus II. Alright, so this is going to our left. Whoops, K minus I. Okay, so for our right, it's going to start off at what? It's going to be starting off at K plus 1, and it's going to be ending at J. And the size, or it's going for our pre-order traversal, it's going to start off at x plus K minus I, and then it's going to go to Y. So this is our right. Okay, so now what we're going to do here is that if I equals to J, meaning that we're basically done here, we're just going to printf in I, and then we're going to return. So if I is greater than J, basically meaning that we have nothing, then we're just going to return without printing anything. Let's see what's wrong here. Ooh, okay, so we have to print out a character like that. All right. So now remember that we have to first print out the left, the right, and then the root. So we're going to print out the left, the right, and then we're going to print out the root. All right, so let's actually test that. There might be some bugs, but we got this. Run heritage. All right. So that's our strings, or our in order and pre-order. Yeah, okay, that's fine. Whoa, okay. So index -1, out of bounds for our character 1. All right. So let's actually do some verification over here. So we found that K over here is going to be equal to 5. So then we're going to start off at the left subtree over here is going to be 0, and that's going to go to 0, 1, 2, 3, 4, correct. And for our pre-order, it's going to go from x plus 1, which is going to be 1. And then it's going to go to 1 plus k, which is 5, minus 0, which is 6. So it's going to go from 1 to 6. So 1, 2, 3, 4, 5, 6. Incorrect. So then over here, this is actually going to go from this to this minus 1. Alright, so over here, yeah, k minus 1. Okay, so let's go try that. Ooh, okay. So board again, it's at line 13, pre-x. So over here, if I is equal to j, if I is greater than j, we're going to return. Alright. So if, okay, so actually over here, this should be if nii is equal to root, my bad. Because we're checking if it's, we're basically locating the root in the in-order traversal. Ooh, okay, again, we have that pre-order of x. Alright, so over here we have from 0 to n minus 1. So what we're going to do here is that we're going to first, for each of those, we're going to printf the root. Then we're going to printf integer, integer, and integer, integer. This is going to be root I, j, x, y. Alright, let's do this. Ooh, okay, I forgot to end line. It's gonna be pretty ugly, so. Right, so for some reason, we have C, B, A, and then we have another A. So that A is actually incorrect. Since we shouldn't actually have that, we should only have one A. Alright, so let's take a look at this. Over here, it goes from K minus 1, okay, K plus 1, J, per X plus K minus I minus 1. Oh, so this should be plus 1 over here. And yeah, okay, so it should go to K, Y. Right, so, okay. So no runtime error. Let's actually remove my debugging thing. Alright, so let's print that. Okay, A, E, F, D, B, H, G, C, correct? So what we're going to do here is that we're going to submit. Alright, so this is that, heritage, language. Alright, so we have to read from heritage.in, read heritage.out, write stdio. Whoa, okay, stdio. Alright, okay, everything good. Alright, let's go over here, select our file. Okay, YouTube is that. Oh my gosh, it's lagging. Alright, okay, over here, YouTube. And what is this? Heritage. Alright, heritage. Alright, so let's submit that. Okay, so everything is correct. If you have any questions, feel free to leave them in the comment section below. Thank you. Bye.